Okay, we've talked about prime numbers. I've mentioned it through most of the videos. Now, if you recall, the real number set is basically the reality that you're going to deal with in high school. And from the real number set, the rational numbers, if you remember this is the real number set. And it's broken up into two sections, right? Now, this is the rational numbers, and this is the irrational numbers, right? Now, as far as you're concerned, majority of numbers you're going to deal with in high school are going to be from this group. Now, this group, the definition of rational numbers is any number that can be expressed as a fraction of integers. And the integers was one subgroup below the rational numbers. So the rational numbers includes the integers, and then we went down to the whole numbers, and then we have natural numbers, right? Now, if you're able to deal with integers, which are just positive and negative whole numbers, then you have this whole section covered, and you're able to deal with the majority of numbers they're going to throw at you in high school. Now, whole numbers can really be defined as prime numbers, because in the whole number set, in the natural number set, any numbers that aren't prime numbers are made up of prime numbers. So let's take a look at the first 20 numbers, okay, from 1 to 20. We got 1, 2, 3, 4, 5, 6, 14, 15, 16, 17, 18. Now, if you ask most people, you say, how many numbers are there between 1 and 20? They'll tell you, oh, there's 20 numbers. But there really isn't 20 numbers. Between 1 and 20, there's only 9 numbers, okay? Now, let's circle the prime numbers. We got 2, 3, 5, 7, 11, 13, 17, and 19, okay? 1 is a special number. It's not a prime number, but as far as you're concerned in high school, you could think that it was a prime number. Now, what were prime numbers? What's the definition of prime numbers? Prime numbers are any natural number that can only be divided evenly by 1 and itself. So, between 1 and 20, there aren't 20 numbers. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay. Now, let's take a look at the other numbers and see why this is so. Now, 1, 2, 3, they're individuals. 2 and 3 are prime numbers, and 1 is just 1. Special number, special case. 4 is not a new number. Okay, 4 can be broken down into 2 times 2. Okay, you got 6. 6 can be broken down into 2 times 3. 8 is 2 times 4, and 4 can be broken down into 2 times 2. So 8 is really 2 times 2 times 2. 9 is 3 times 3. 10 is 2 times 5. 12 is 2 times 6, and 6 can be broken down into 2 times 3. Okay. 14 is 2 times 7. 15 is 3 times 5. 16 is 4 times 4, and 4 can be broken down into 2 times 2 and 2 times 2. So 16 is really 2 times 2 times 2 times 2. When you're doing the tree diagrams, what you do is any number that branches off, you kill it. So those guys would have been dead. So 16 would have just equal to this. So you take the ends of each branch. 18 is 2 times 9, and 9 becomes 3 times 3. Again, the 9 dies. 20 is 2 times 10. 10 is 2 times 5, and the 10 dies. So 20 is really 2 times 2 times 5. Okay. Now let's do a couple other numbers so you get this down pat. So let's take, I don't know, let's take 100. Okay. Actually, let's take 10,000. Now, these should be the easiest numbers you get. If you want, we'll kick this up to 9,000, okay, or 90,000. Okay. So what you do, if you get any number like this, the best way to do it is take the number by itself over here, and take all the zeros, 1, 2, 3, 4, and you put a 1 in front of it. If this was 29, you would have put 29 here, and 10,000 over here. Now 9 is just 3 times 3. 10,000 is 100 times 100. And 100 breaks down into 10 times 10, 10 times 10. Okay? And 10 breaks down into 2 times 5, 2 times 5, 2 times 5, 2 times 5. Okay? Keep in mind, these aren't 25s, it's 2 times 5. So all the numbers above this, you can kill. And you take all the n branches to figure out what 90,000 is as expressed as a prime number. So 90,000 is really 3 times 3, 2 times 2 times 2 times 2, 5 times 5 times 5 times 5. So you have 3 times 3, 4 2s, 1, 2, 3, 4, and 4 5s. 1, 2, 3, 4. That's what 90,000 is. Now, once you start dealing with exponents, you can express this more simply as 3 squared, okay, times, you got 4 2's there, so it becomes 2 to the power of 4, and you got 4 5's, so it becomes 5 to the power of 4. And this is 90,000 in its prime form, simplified into its prime factors. Let's try something else. Try another number. Let's do 448. Now 448, that's an even number. Even numbers can always divide it by 2. Okay. So 2 goes into this, goes into 2 twice, it goes into 4 twice, 2 and 4. That's still an even number. You can divide it by 2 again. That becomes 2, 1, 1, 2. That's still an even number. So 100 divided by 2 is 50. 12 divided by 2 is 6. So 112 goes in, is divided, becomes 56. Okay. Now that's still a prime number, so you can break it down. That's still an even number. You can still divide it by 2. So 56 divided by 2 is 50 divided by 2 is 25. 6 divided by 2 is 3. 25 plus 3 is 28. 28 again is even number, so this becomes 2 times 14. Now 14 is an even number, it becomes 2 times 7. Now 7 is a prime number, 2 is a prime number, you're done. You get to the end of the branches, end of the trees. Now what you do is you kill these guys. Whatever branched off, you kill. So 448 is really 1, 2, 3, 4, 5, 6 2's times a 7. Okay. So this becomes 2 to the power of 6 times 7. 2 to the power of 6 means 2 multiplied by itself 6 times. Easy? Once you know how to do this, life becomes a lot simpler managing numbers, especially irrational numbers. Well, specifically irrational numbers. Because any rational number can be broken down into prime factors. And rational numbers are just integers that can express as a fraction, that are numbers that can be expressed as a fraction of integers. And what are integers? Positive, negative whole numbers. And whole numbers are really natural numbers. So prime numbers are natural numbers that can only be divided evenly by one in themselves. And anything that's not a prime number is made up of prime numbers. You have to keep that in mind. I'm going to continue to say this. Anything that's not a prime number is made up of prime numbers. So when you're dealing with the rational numbers, if you can break them down to their prime numbers, you know what they're made out of. And that way you can manage them. You can deal with them. You can simplify the numbers down.